We'll now initiate recording. Okay, so what I've just done is I have gone through the first set of steps here where we have set our access tokens and our access token secrets per our Twitter application that we created. You recall that we created that, I think, maybe the time before. Okay, and we've been using Twitter in two contexts. On the one hand, a context where we query through the system Twitter4j. We actually query Twitter's databases. And we could do so by geography and by time and according to a query text. But fundamentally, we were getting historic data. The other capacity in which we were accessing Twitter data was a streaming capacity. So here, rather than asking about recent texts ourselves, but rather than pulling them ourselves, we are pushed them. And they are pushed to us via a mechanism known as Twitter streaming. And it turns out that that is well supported within Spark. Okay? So today we are going to go through an additional exercise associated with Twitter streaming, which will allow us to maintain state in Twitter. By state, I mean it's going to be updating status over time, the memory of what's been received. Now, we already did this to a little bit of a degree. Does anyone remember, how did we maintain state previously? How did we previously maintain state in Twitter? In what way? Well, there are two primary ways. One, we maintained a count, a running count of the number of Twitter messages received. Does anyone remember that? Mm-hmm. How do we do that? Through use of what mechanisms?
So one was counting the RDDs?
Yeah, with counting RDDs. That's true. Or we could do it with the stream itself. In either case, what mechanism did we use to maintain that state? Does anyone remember? Well, we used a variable that was a synchronized variable from Java called atomic long. Mm-hmm. Remember that? Mm-hmm. And this atomic long basically allowed multiple threads of operation to synchronize their access to the state, so that one wouldn't read it at the same time basically as another. One overwrites it and then the other overwrites it and the first update is lost. Instead, we did what an atomic operation called get and add. Do you remember that? I will actually go show that. Okay, so just as a recollection, we declared two atomic longs, one associated with running tweet count and one associated with running count of possibly notable tweets. Do you remember that? And then we could use this atomic operation called get and add here, whereby we could, in one operation, in an indivisible operation, we could read the current value of this and increment it by this, and then return a value as a result, although we're throwing away that value. Get and add also returns a value. It's a little bit like the ++ operator in C++, Java, and C. So here, in a single indivisible operation, we get the current value and add to it. So if there are two in a race condition, two different threads, maybe associated with two different processors even, and they both try to get that, one will go before the other. The other's operation will be indivisible from the perspective of the other. It'll get it and increment it before the other can get it. It's a very important principle with operating systems, okay? And to do that, whoa! we use an atomic long, right? Not a Michael long, not a Jeffrey long, but an atomic long. Okay. So, ladies and gentlemen, this is how we updated state previously. Now, there's another way, which if you had said that, I would have given you the benefit of the doubt. We print things out, and that's actually there's state associated with that, just sort of what's printed. But this is the primary way we use these atomic longs. Now, that's great to a degree. First of all, I have some doubts about this. First of all, I'm actually not certain that these atomic longs will work properly if the RDD is spread across multiple machines. These are actually constructs from the Java library, not from Spark itself. And I'm actually not sure if you had this running out as Winchell anticipates, running out across large farms of machines. I'm actually not sure these single atomic longs will actually correctly synchronize everything across that set.
Exactly.
It'll just be local operations across multiple processors on your own computers. And the second thing is they're somewhat impoverished from the standpoint of the type of information recorded. They're not very structured. Here, there's two pieces of data, two long values, long integers. And with all due deference to other distinguished longs in the department, these longs have limited information to store things. So the question to which we will bend ourselves today is, how are we going to maintain data, which is not global data that's updated only for globally for the current state of the application, but actually needs to be maintained based on the values received. Based on the values received over time. For example, the number of places we've seen, and the number of time we've seen those places, or the number of tweets from a particular user, or the number of different keywords we've seen. All of these are things where we might have a growing number of different pieces of state we need to maintain, with different users and different places and different hashtags. We might not even have a clearly definable set of them. We want to store more information, or maybe we want to keep track of how many times we've seen each word. The number of times we've seen each word so far in the tweet streams. How are we going to do that? Well, we're sure not going to do it with a single number. Instead, we need numbers that are maintained almost per data item that of which we're keeping track. And that, ladies and gentlemen, is the task to which we put ourselves. We place ourselves. We steal ourselves. Okay?
Atomic array.
It would be nice, but it turns out the truth is more pleasant and more scalable. Okay? Okay, ladies and gentlemen.
Stream of atomic.
Okay, so what I'd like to do is go back to here, and we have set up the beginning of our operations. We created a new streaming context, and we should have done sc.log set log level, and set it to be error-based logs so that we don't see lots of cruft. Now, I'd further like to undertake one thing that we have not yet seen. You notice this, we created a streaming context here using this Spark context. What we will want to do now is we will want to do a checkpoint. Okay? Now, I actually have a folder, as I am wont, in my my Spark and Hadoop thing. I created a folder called checkpoints, just so we don't have to put checkpoints all over the current level of the folder. So I am going to go back to this, and I'm going to say ssc.checkpoint, And you may wish to do this. I'm going to say checkpoints. Okay? And I think I could do a slash there. Okay? Is my recollection. Boom.
Sorry, this is a file already that you...
So this is a folder. Basically, ladies and gentlemen, when it comes to Spark streaming, you can imagine handling streaming data as it comes in. Fine. As long as you're not maintaining any state. But once you maintain state, then there's the risk of losing state. Once you maintain memory of what's happened, the number of times you've seen each place, or number of times you've seen each keyword, you're going to need to find a way to remember that. So even if the machine crashes, that information is not lost. Now that may seem a tall task, but remember, that is the task to which Spark aspires, to support huge farms of machines. Could be tens, could be hundreds, could be thousands of machines of the sort that Google employs, for example. And they want to be able to run Spark across all of them. And guess what? The world's an ugly place. Machines are going to go down. And you want fault tolerance. You want resilience. This is one of the big goals of Spark. It's to be able to rederive things if they've been lost. That's one of the goals of having these things be functionally defined. You know the complete lineage. So if some data is lost, no problem. You just recompute it. You just read it in and recompute it. And similarly as with this, if you're maintaining state over time, you need to be able to read it in if the machine goes down and you need to bring another machine up in its stead. You want to be able to go retrieve that information. So this is why you're going to have to specify a checkpoint, and that information will be required when we start using the state, as we will shortly. Okay? Next.
Checkpoint is updating in a time manner?
Sorry?
It is updating itself?
The checkpoint, yeah. I think it's periodically updating the checkpoint. I actually don't know off the top of my head what the timing is, but I think it's dictated. So basically, it tries to keep it essentially current with the current state. Okay, and this is very indicative of a lot of systems in computer science. We have what are called log-structured file systems, for example, and they keep enough information on them. They keep a log of operations, so if it crashes, they can replay them and get back to the current state, for example. Okay, so this notion of fault tolerance is important. Okay, so let's perform some imports, if you haven't already. Import Twitter utils, import Spark streaming. I really should have done this all at once, and if some of you were so inclined. Seconds, streaming, context. Okay.
Isn't seconds just in streaming but not in Twitter?
Oh, thank you. Yes, you're absolutely right. No, this shouldn't be Twitter here. This should just be this. So there's Twitter streaming, but then there's also these guys or gals, and then import or.apache.spark.sparkconf spark context. Okay, I think what we need to do our job now. Okay, so remember, you're going to do this ssc.checkpoints, and you could just do it with a checkpoint of dot, but be aware that your file system will be littered with folders that you may have to pick up, much as these have littered mine. Okay. Okay, now we're going to do the following. We're going to create a tweet stream. How will we do that? As follows.
As before?
Yes, tweet stream, indeed. Twitter utils dot create stream ssc none. Okay. And you note that earlier we had created a streaming context with this for seconds. So if you didn't do that, you'll have to do it before this guy here. Okay. This SSC has to be defined by this guy, the streaming context. This is saying what? Yeah, every 5 seconds. It's going to be updating every 5 seconds. Okay, ladies and gentlemen. So what we're going to do is we're going to do the following. The first thing is we're going to be extracting information on places encountered, okay, in the tweets. Okay? So the way in which we're going to do this is we are going to use a couple of features that we've already been using, namely use of option values in place of null references, checking null references directly. Okay, so the first thing we're going to do is we're going to extract from the tweet stream. We're going to extract a stream of places and counts. Okay, so this is what we have to do. We are going to go and do the following, and I think this should be fine. So val place count key value stream. We're going to have places as the key, and value will be the number of times they've been encountered. And it's very common within this context, and indeed within big data, that we have these key value structures. So we're keeping track of data for certain information, associated with certain information. So we're going to say tweet stream dot map, and of what is a tweet stream composed? What are the things flowing in the tweet stream? Their statuses, the status associated with the Twitter. So what can we do with a status? Well, if we look with this status, we can do, you may remember this, we can get when it was created, we can get the geolocation, we can get the language, we can get whether it was retweeted, we can get the user. In this case, we're going to get place. But we're going to do this with a twist. Because get place, ladies and gentlemen, may sometimes be what? Null. So we're going to wrap it in an option. And by so wrapping, by so doing, what that's going to allow is, this is a nice feature of option. If you give it something which is null, guess what the option will be? None. And if you give it something that's not null there, it'll create a sum of it. S-O-M-E. Okay. So, ladies and gentlemen, you may ask, well, what's the difference between null and none? Well, the difference is huge, because you can apply operations to none, like map, like flat map, like filter, like reduce. You can apply those to none in a way you can't with null. If you try to apply map to null, bad things will happen. I heard it once claimed that the Roman Empire fell because of null pointer exception, but that's not true. But bad things do happen. And the person who invented null said it was $1 billion mistake, and I disagree because I think it's higher than that. Is defined. Unfortunately, sometimes industry settles for mediocrity in many things, and null is one of those things they've settled on. So then we can filter it, and we can simply ask, is it defined? So we're going to get out of here an option, and we only want to use those for which it's true. So in other words, which contain a value, some value. And ladies and gentlemen, next we are going to, for those for which is defined, we are going to in fact we're going to map them to the name of that place. So for those, this is our little pipeline. For those that are defined, we will take in an option value that encodes the place, and the place is encoded as a Twitter4j place. just like that. A Twitter4j dot place. Okay? It's an option that holds that sort of thing. It's a monad. Okay? And having done that, we're going to create a key value pair. So it's going to be a pair. The first thing is going to be the key. The second thing is going to be the value. And in this case, ladies and gentlemen, we are just seeing, we're just going to be, for each tweet that contains that place, that is from that place, we're just going to have a value 1. That indicates a single tweet from that place for this tweet. Okay? So this is going to be 1, the second part of the tweet, of the pair. But the head of the pair, the first element of the pair, is going to be what? Well, it's going to be the full name associated with this place. And one way to do this is to say p.head.get full name. This head, don't be confused. This head is just getting the value in the option. And I think there's another way to do it. I think you do get or something like that. But that will let you extract. This will let you extract whatever's wrapped in the option.
Can you use an underbar 1?
No, I think that's for tuples. I think that's tuple specific. Good question. I think you might be able to say get this, but in any case, I'll just do head here. Okay. Okay, so ladies and gentlemen, did I close my parentheses? Am I forgetting one parentheses?
You're still on the map.
Sorry.
Oh, no, you didn't.
No. I think it. Hey. Yes. Okay. So this is what I have. So first, it's basically going to extract places, whether they're null or not. Those that are null will be none. Those that are not null will have some here. This thing is going to filter out those that are none. This thing will take the remainers, which all are sums, S-O-M-E, and it will extract from them the full name and pair it with 1. Okay? And so that will be a stream of, so there's the tweet stream. This is going to be a parallel stream, you could think of it, a sort of corresponding stream, where for those tweets that actually have places, this will hold a pair of the place and a number. And this, ladies and gentlemen, is the key to updating the state. Okay, now we're going to use the key operation, which is a somewhat confusing operation. So I'm going to try to take pains to explain it. And the operation here is going to be called update state by key. Okay? Now, update state by key is going to take in a function. Well, first, it's going to be called on the new data, this stream. It's going to be called on this stream. And it's going to take in a function that says, for a given key, how to update the data that's already been accumulated, the accumulated data associated with that key with the new data. So we're going to call update state by key on this guy, and we're going to pass it a function that says, for a given place, how do I combine the new value for that place with the accumulated total for that place? Which might not even have been totaled up yet. It might be the first one, in which case it will be none. It will be an option. Okay, ladies and gentlemen. Okay. So now, in order to do this well, we are going to create a function, okay? And I am looking for, okay, so So pardon me for a second. New place count. Okay, so new key phrase. Here we go. Okay, good. So let's define that function. So this function's, we're going to define it as a val rather than as a def. A def defines a what? Method. A function is a value itself. We can turn a method into a function in Scala by doing what? You can put an underbar after it. But, ladies and gentlemen, here we go. This is going to be a function. It's going to take in two things, namely, number one, the running total for this place, which is going to be an option of int. And secondly, any new values for this key. And note there can be more than one, because a given time that it's updated for the full batch, there might be several mentions of this place, several tweets from this place. Okay? So it's a whole sequence of them. So here we go. We are going to take a function here, and it's going to go like this. This outer paren is going to go around the entire function definition. This is going to take new values for a key, and this is going to be a sequence of integers. A sequence because we might have more than one tweet that mentions this place in this given batch. There might be several that mention it in this dstream batch. In this given update, we might have several tweets that are from this place. And so in general, there might be more than one of them. Next, we are going to have a running total. And this is going to be a total to this point for this place. This whole guy is going to be specific for this place, ladies and gentlemen, for a particular place. Okay. Okay, so this is the set of all new values. This running total, maybe it's the first time it's been updated, in which case it will be what? Yeah, it's going to be an option of int here. And so if it's the first time it's ever been updated, it'll be none. Otherwise, it'll hold a value. Okay? Option of int, ladies and gentlemen. Option of int. Okay. And this, it turns out, needs to return. By the way, notice this closed paren, it's matching this one here. So this is our parameter list for the function, or providing a function. It takes in the new values and the cumulative total till now for a particular place. These are the new values for a given update. And it's going to return, I think that's right, I think it's for the current update. And it's going to return an option as well. It's going to be the current state going forward. Okay, so it's going to return something. This guy here is matching this other one here. So what is it going to return? Well, what do you think has to be done with this? If we have, let's suppose this option of int holds 10, and we have a sequence of int that's 1, 1, 1, 1, 1, 5 of them. What's the new value going to be?
15.
15, indeed. So the first thing we need to do is we need to find out.
Can you go running total plus new values for key.sum?
Oh, that would be beautiful.
But you can't.
But you can't. Why not? Why not? It's almost as beautiful. What if you did that? What would it say? Say you're adding an option to a number.
Oh,
yeah.
right.
So you have to do get or else. 0. So get or else of 0. What does that mean?
That means if it's a none, you return 0.
Correct. Otherwise, it returns its value. Running total get or else 0. Aren't options great?
$1 billion success story.
Yeah. Yeah. New values for key dot sum. Okay. 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 And that's 0 if there's none. Okay. Here we go. And we need this balance there, and then one more for balance. Okay. This guy here matches this guy at the start. So this whole thing is a function. Here are the arguments to the function. There's 2 of them. The running total till now and the new values to incorporate. And here's the value it returns. It's going to be the running total plus the sum of all the new ones. Is that clear? Ready? Okay.
No anticlimactic.
Okay. Oh, I should tell you folks, because I've enjoyed the pleasure of its acquaintance with some delight, that Greg Oster has set up a machine called cmpt898.ustas.ca for use by this class. It has Spark installed. It has some additions like Breeze installed with Spark. And soon, maybe now, it will have the Twitter extensions and it has the Cassandra connector on there, etc. So that machine is configured with Spark on it, and I'm using it, and it's a pretty fast machine. I think it has 8 cores, and it's really nice. You can do things faster. Sorry.
Where is it located?
Somewhere in the department. I don't know, but I mean you just SSH to it.
Oh, okay.
Yeah, I'm not quite sure where it is physically. It's a good
It's in
question.
the cloud.
Okay, so that's our function. Okay, it is a strange world that I don't know where it is. I don't particularly care that much where it is.
Separation of concerns.
Yeah, exactly. David Gifford once said, you don't want a interconnected world to mean that if someone trips over a cord over there, it crashes my computer. You'd like resilience and not have to worry about things. Decoupling of worry. You may have interconnection, but you want decoupling of worries. Okay, so ladies and gentlemen, we're going to now take this stream and we are going to call on it update state by key. Let me make sure that I'm correctly recording this. Okay, for those who are not here, I want to be update state by key. Now, there's a little bit of a twist. You have to type parameterize it by int.
I don't have that function auto-completing.
Is anything auto-completing on this?
Uh-huh.
It is?
Oh. Yep.
Okay, so here I'll so this is this stream here, right? This was a D stream, and so if you do this, it should be update state by key. No?
No, it doesn't. Is yours auto-completing?
Yeah.
Oh, okay. Maybe I didn't import something.
Update state by key. Yeah. Is it? Do you get these others?
I get some of them.
You get a Twitch stream or things being imported correctly, especially those two.
Good call. Yeah. Okay. Update state by key, and then we're going to give it this function we just defined. Sorry?
Something's going on weird there.
fn new place. There. This is this function that we just defined, which adds things together. So on the new data, the stream of new data, we are basically telling it, okay, use this function to update the existing state maintained. The existing state. And so it's going to take care of giving it the running total. This is the thing essentially on which we've called it, and it's going to update the state and save it away. Okay? So there we are. Kurt, does yours exhibit truculence?
Yeah, it's not auto-completing, so I didn't try it.
Okay, maybe you could. There was life in the universe before autocomplete, and I grew up in that environment.
Overloaded definition, it said.
Oh,
I don't know.
okay. Okay, ladies and gentlemen, finally, this thing that we just updated. Okay, we're going to say print 10. Probably when you folks were about when you were being born, I was going around with large parts of the C standard library in my head as to what the order of the parameters were, what each of their types were. Like, like stir copy, which one occurred first, and etc. We had to just memorize that stuff and carry it around, and then we could just do it. It would be really slow if we had to look it up. So yeah, that was
our
it.
brain are not doing the hard work.
Sorry?
Our brains, it's not doing the
No, you're actually doing the hard work. You don't have to do the silly work of kind of figuring out what the order of the thing is. Basically, a lot of the simpler things are being automated now, so that you have to focus on the harder things now. And it's true with like that for a lot of computer science. A lot of simpler things are automated, so we don't have to worry as much about the vagaries of memory layout and all that sort of stuff. But now we have to worry about building larger systems and connected systems, and increasingly it's about the human theater and about systems effects and getting systems to work together at scale. Okay, so now I'm going to do ssc.start. And what we should see
Sound process.
So what is this? What apparition do I see before us?
These counts?
Those are counts. And whence did those come? What thing and what we entered generated these counts?
Print 10?
Yeah, this print 10 thing.
Huh.
What are these that are printing out? Well, these are the results of this. I printed the results of calling update state by key, and guess what that returns? What does that update state by key return, do you think? It's called on the new values. Gosh. It's called on the new values. What does it return, do you think?
A tuple.
The updated states. The updated state is what it returns. Update state returns a stream of the updated state. And this is printing out the stream of the updated state. And if we watch it here,
It's really giving us the top.
and really, yeah, but that's because I did 10. I should have done, 100, something like that. Okay, okay, don't. I'm glad I didn't do that. So it's.
Once you start, you can't go back.
Yeah, so if we had done a larger amount, we might be seeing some repeats by now. Soon enough, probably within 15 minutes or something, there'll start to be repeats here. Where it'll start to,
Sending out.
what's that?
There's already one.
There's already a repeat?
Brazil.
Okay.
I don't have it.
Okay. Yeah. Okay, so ladies and gentlemen, here we're maintaining state on a per place basis. Okay? Now, you can tell me, how would we keep track of the number of times a given word has occurred in tweets?
I suppose much the same way.
Much the same way indeed.
Instead of pulling out place, you pull out words.
Okay? Do we want to do it?
Sure.
What do you think? Okay, ladies and gentlemen, I don't have notes in front of me for this, but I think we should be able to figure it out. Okay, first of all, why don't we stop this? Okay, I'm quitting out of this, and I'm going to go back and sort of reinitialize it.
But
Okay,
you can just stop this CC.
that's probably true. SSC.stop.
Right.
Isn't that
Okay.
we had
You
that problem
don't need
before? You
to-
can't start it again.
You need to
Redefine it.
redefine the stream again, but you don't need to
Okay.
give the authentication.
Is that right?
Yeah.
Okay. I'm going to. So I think that's a great suggestion for anyone who wants to try that. That's fantastic. So the idea is that you have to define this tweet stream again. So you do ssc.stop, then you define the tweet stream again, then you can say ssc.start.
Yeah.
And
Thank you.
okay. As normal, Aiden is one or two steps ahead. That's great. Okay, I meanwhile am one or two steps behind. So I'm gonna pause the recording for our internet viewers, and we'll be right back after this break. Okay, so what we've just done is we've just gone and re-entered the imports needed. We've gone and re-entered the setting of the properties for the access token and the consumer key and secret and the access token secret. We've entered them, and we have gone and
Did you say your log level?
I did do log level, yes. Actually want to pause. Okay, and we further set up the SSC to be based on the current Spark context with 5-second intervals, and I set up the tweet stream in this way. Next, I am going to do a checkpoint, ssc.checkpoint, and this is going to be checkpoints on my computer. You could do dot there if you don't mind the pollution of your file system. Okay, great. Okay, so what do we got to do in order to harvest the words and keep track of the number of times a word has occurred? What do we have to do?
To get the text of the tweets.
Okay, so we have to get the text of tweets. And whence will the text come? How can we extract the text? What's a good place to start? Start with tweet stream. Okay, so we'll define a set of streams and process them sequentially. Okay, so here's val words.
Word count? No words.
Word stream. Oh, yeah. We're going to take the tweet stream. And what do we have to do in order to get the words? What's the first operation to get the words?
Tweetstream.map.
Tweetstream.map, and what do we map? What does each tweet consist of in the tweet stream?
Status.
Status, and we map that to what?
We probably don't need an option here, right?
No, we don't. We map it to get text. All tweets have text.
That's what they are.
That's what they are. Okay? Okay. Now, what could we do to turn this text into individual words?
Split it. Or flat map.
Ah, it goes back to our first day. Okay. So what do we want to map? fact, we could even do it at one thing here, but this is kind of conceptually nice. We got gives us the text of the tweet. What do we flat map? What does the flat map take in? What sort of operation? What sort of argument?
Something that maps to a collection.
So it's a string of the tweet
So this
text,
is where we split the string.
right? This is where we split it. The split. Now,
By space.
we could split it by space. There was a nicer way we did this on the first day. Does anyone remember? I think we could do it with a regular expression, actually. What do we...
R.
Can we do something like this? Like, like this? Or no?
I think you can do that. Although,
Does split take a regular expression as an argument? I'm pretty sure we've done this before.
yes.
It does?
I see
Okay.
like also having to put like an R at the front.
It's not actually not. Let's distinguish this. What does this R turn it into?
Regular.
A regular expression. The raw at the front
Right.
treats it as a raw string. And what does that allow us to do? Why is that a favorable? Because this backslash is not interpreted. Okay? So alternatively, what's the alternative to that in Scala? You can put 3 quotes around it. I'm not certain that this will work, but let's give it a try. Stir tweet text. It should be stir tweet text. Okay, no, it doesn't allow that. Okay, here, let me pause it. So actually, we don't even have to turn this into regular expression. We could just give it like that. Okay? Note that doing this is the same as doing this. The point is that it's preventing this backslash from being interpreted. Backslash S being substituted by Scala itself. Protects it from Scala thinking that it knows that it's secretly a certain thing. Word stream, ladies and gentlemen. Word stream. Why is this flat map?
Are you still paused?
No, I think why is that flat mapped rather than mapped?
Because we're giving it something that maps to
To a
container.
collection.
So we want to.
Yeah. We want to flatten it. We want to. So, ladies and gentlemen, this map is just 1-to-1, right? For each status, we're extracting the text, right? It's 1-to-1. For each status, we get a text. Here, it's 1-to-many. For each text, we get a whole bunch of words, and we want to create a stream of words. So we apply this to a stream with a flat map. And the flat map here is used to allow it to, we've used it before to sequence things with monads and so on. Here it's used for a very prosaic purpose. It's just being used to allow each state to be mapped to many. But interestingly, there's an underlying conceptual connection between those. Okay, here's our word stream, ladies and gentlemen. Given that word stream, what are we going to do? What did we do before? Let's suppose we just want to record the number of times any word has occurred. To simplify things. What might we do here?
We created that function that had key value.
Okay, there's a function, but what did that need? It needed 2 things, that function. 1, the running count. 2, the what? The new. And what was the new thing on which we called it? It was a stream of what?
Sequence of ins.
Was the new thing on which we called it? On which we called update state by key? It was a stream of what? Remember I put the comma first in the middle of it?
Yeah.
What was it?
The one.
It was a stream of
tuples of.
Yes, it was a tuple string. Where are the tuples? Are these tuples?
No.
No, we have to create our tuple string. It's going to be a set of tuples, a stream of tuples that will indicate the new values, how many new values there are of this. So what will it look like? We'll call it pair stream. And what is it going to look like?
This is a function though, or no?
It's going to be a stream. And what will this look like? Remember that function, it operated on two things. It operated on a running count and new values. And those new values were a sequence, you're right. But whence did that come? Update state by key was called on a stream of pairs. Remember that? Something comma 1? Remember or not? So we want that same thing. So how are we going to transform the words into pairs, the corresponding pairs? This is going to encode our number of new values. So each one is just going to be 1 as well. So how are we going to do this? Tell me what to type.
We can zip like one. Something.
That would be, actually that would be nice, but zip would be if there were two streams and we could zip them together. All we need to do is something much simpler, actually.
Map and then
Word stream dot map and map it. So given a word, what are we going to turn it into?
tuple with a word and one.
Exactly. Word comma 1. Oh, this is beautiful. Good or not? Okay, ladies and gentlemen, a pair stream. Now what are we going to do? It's good it's a pair of it and not a pear tree. Okay, so ladies and gentlemen, what do we need to call on this?
The function.
Yeah, we're going to be calling on this. Don't do this yet. I'm just doing this for a point. What? What's the function?
Update state by key.
Update state by key. But in order to do that, what do we have to pass update state by key? Remember, update state by key is going to take in something and it's going to return the updated state. Remember, and then we printed it last time? We printed the first 10 or first 100. Remember that? Remember or not? Okay. Okay, so update state by key. What does it take in as an argument? Oh man, wish I didn't have those things popping up. What is this update? It takes in a what?
Function.
Takes in a function. And so we have to define that function. So here's going to be val update. So val fn new state for word count, something like that. What do you think? Good or not? Okay, we're going to start with parens around the entire function. What is the function going to take in? So there's going to be a body here, and there's going to be some arguments here. What are those arguments going to be? The first one is the
Word.
this is the new values for word, and this is going to be just to emphasize it's all new values. There might be many copies of this word, like a or to or hello. Some tweets of other words that are less favorable.
String.
Yeah, so this is going to be actually, no. So this function is going to actually be called to update the value. So it knows it's specific to a certain word. This is going to be a sequence of int. These are the ints associated with this particular word. This is actually going to be called, each time it's being called, it's for a specific word. And it's updating the state for that specific word. So it doesn't need to encode the word here. In fact, you don't even have access to it. There's actually a newer version of this function in Spark that actually does give you access to the state, but it's somewhat more complicated, so I'm not covering it here. So new values for word, and what's the other thing that it takes? What was the second argument? It was the running count. And what was that?
Int.
Was it just an int by itself?
Option int.
Option int. Eh? Okay. And now what do we need to do? Have we seen this before? What do we need to do here? Let's put parentheses around it. What do we need to get back? Okay, so if for a particular word, which we don't know what it is, but this is being called for each of them. What's that?
Sum.
Yeah, okay, what are we summing up?
We need to do running count.
Okay,
Get value.
running, sure, we could do it that way. Either way is fine. Get what?
Was it head? No.
Get or else.
Oh,
0. So if it ain't nothing there, we'll have 0. Okay? Plus
right.
new values for word dot sum. Good or not? So this is matching this guy here, and then I'm going to put the one for around it. There we go. Good or not? The response lacks conviction.
Oh, it's lazy, so we'll see if it's good.
Okay.
The rubber has yet to meet the road.
Okay. Ladies and gentlemen, now what can we do? This pair stream, this is like the new state, right? All of these are 1. It groups them together here. For a particular word, it calls this. It groups together all the things for that word, which happen to be all
Once.
1. Now, currently, I think actually in a general context, it might actually sum those up. But, well, no, it's probably all 1s here. Okay, and then this is the running count, which is, an option. And so, oh, gosh, sorry, folks, we did something bad. What did we do bad here? We forgot a key thing.
Do you have some?
It needs to be sum. Not SOM, not SUM, but SOME.
Apparently, it was not good.
Goodness of the lazy evaluation.
That's right. Okay. Okay, ladies and gentlemen.
So the correct answer next time is some good, option good.
Right. Yeah.
Oh, that's nice.
Yeah. Eric sent a note to some people saying in the subject line, I think it was purely a mistake, but he said, Nate's so good.
Almost.
Yeah. That's right. Control T on Emacs would fix that. Okay. Okay, ladies and gentlemen, so what do we need to do? This is the new state. And what do we need to do to finish the thought? Okay, so here's our function. What do we need to call? What do we need to call? Are we going to call this thing directly? Who's going to call it for us?
Pair stream.
Sorry? Okay, pair stream. Yep, good. Then what? Update state by key, and we're going to come back to the beginning of this. Pair stream update state by key, and what do we pass it?
Function.
we pass it this function. And this is going to eval, what should I call this? Val word counts, updated word counts. How about that? Updated word counts. That's after they've been updated. Good or not? Hmm? What do you think?
I mean, I was thinking maybe you can just really sort the print before you should print. Just get the most frequent query.
I like that idea. So, how are we going to print this out? Okay. Now,
Is there an order by?
I like this. Save as object files. Not what we want. We're going to be coming to that later. But we'd like to be able to sort this. How are we going to do that?
It's a stream, so
It's a stream.
you have to array it or something.
Or just string.
Well, maybe one of you can figure that out. Let's just do this for now. Print the top 100 of them. So just remember, by calling this on a stream, what is it going to do? Well, every time, it's going to be printing up the first 100 of them, right? Mm-hmm. Ready? ssc.start. Ready or not? I suspect we'll see a mixed basket of languages.
Yeah.
Some words that are less than kosher.
Oh my gosh, look at that, it's a flame thing.
Everything's one still. Oh, I have me 21.
Let's see, like.
Win is 5. My is 29. It's actually a lot of different words here.
It's not in any particular order, though, is it?
No, there's some Korean.
We can have our own dictionary and then.
Looks like China may be still asleep. Oh my gosh, that's kind of...
Senpai bot. You could pull out all the hashtags using a regular expression.
That's right. Yeah. Okay, so this gives us some sense of the diversity of, in many senses, of content. Twitter, 12. Yeah. Quite.
And then you could probably also add on a calculation as a result of, from the tweet, and then store that number. So the calculation could be some sort of sentiment score.
Right. Right.
And then you store the different scores.
Yeah, and sort of the number of each of the versions of that score, what have you. Score 1, score 2, score 3. Yeah. So, ladies and gentlemen, this is state. Now, Kurt, if you were to keep track of just a few scores, 1, 2, 3, a small number, maybe you'd want to have just global state. But this method is particularly favorable when you have categories which grow over time, or which can't be defined up front, for example. And you could use it. So we noted earlier that atomic long is actually not robust given multiple machines, because multiple machines won't have access to the atomic long, because the atomic long is living on a given machine. What you could do, though, is modify this strategy so that you have a stream of sort of category results, and you update those. you call update state by key on the running total, and it maintains the running total for each of those. So you'd have to map. You could map each word, each tweet, Kurt, into bins according to sentiment score. 0 to 10 or something, and each bin could have a number associated with it for this batch of tweets, and then update state by key will combine it with a running total, and then you could print that out. So that would work. Right. So here you could see we've quickly exceeded our 10 word limit. I mean,
100.
it's our 100 word limit. Yeah, it's quite.
Are these
quite
being
fun.
saved to file?
Not yet. We'll see how that could be done.
We have the. What was the
Here.
snapshot folder or whatever we specified?
Yeah, well, those are being saved away enough to allow it to restore if it crashed. Though I think there'd be some code you'd have to write to sort of help with that. But that is being stored away. But what's not being done right now is actually storing these to a file. We could do that, so maybe we'll just see how that's done right now because it's pretty quick. So ladies and gentlemen, we had this updated word counts. Oh yeah, it's gonna be difficult. So I guess we could do ssc.stop is what you're saying? ssc.stop. And this is okay, I guess. It's sort of par for the course. Okay. So one thing that we could do would be to do, we're going to go get our tweet stream.
Before that, you need to create this.
Oh, this one?
Yeah.
Okay. Streaming context. Thank you, Ed. As normally, you're just a great
I think
resource.
It's okay. I think even if you don't have this.
Okay, we'll try it.
Okay.
Yeah. And then we'll set the tweet stream based on this. Hmm? Okay. That's amazing. Okay. I've been trying to write down the things I learned from Aiden's
No.
suggestions. That's actually really good. This is fantastic. Okay. Okay, so ladies and gentlemen, one thing we could do here, updated word counts, we could say, and I think you have to do it this way, map partition, repartition. You can map it to a single partition. What that's going to do is, basically, if this is running on multiple machines, or if it's running on multiple processors, it will basically make it so that this creates a stream, which is going to be running on one processor, and then you could do, is it write or save as text files. Save as text files. And you're going to specify a prefix and a suffix here. Now this is a little bit confusing. The prefix here is actually going to be a combination of the folder and the file name prefix, which is, by my view, it's a little bit strange. So we're going to put them in the output folder, and this is going to be how they look here. Okay, so this is going to be output/output. This is the beginning of the name, and this is going to be the folder, which are called, or you could call it outputs. It'll create a folder if you don't have one. And this is the beginning of the name, and it's going to append after that the time, a representation of the time. I think this is Unix time, number of millisecond since 1970, I think. Okay. Okay. Next. Okay. Next, we're going to put any suffix that we want to put here. So you could say, for example, word counts. Word counts. And you could put txt. Yeah, right here. But you could put txt. Yeah. Okay? This is going to actually save this count each time to this place, and it's going to further put in this name, which indicates when it was written for that update. Are we ready?
There will be separate files, right?
So it's going to be separate files each time. It will, like, this is one group that did it, and then now if you didn't do this repartition, it would actually be, because your machine might have multiple cores, like 4 cores, it would actually write 4 at a time onto your machine, which would not be favorable. You notice, however, that each of these is itself a folder. And we can open this here. Yeah, I mean, each of them is a folder, and so these are various tweets.
So
Yeah.
these are the different RDDs you have on each of the partitions.
The partitions associated with the RDDs, yeah. So RDDs, resilient distributed data sets, I'd like to emphasize the distributed. It's distributed in the sense they can be across multiple processors on a machine, multiple machines. And if there are multiple processors on your machine, when you do this write out, if you didn't do this, it would be putting out one for each processor that have been assigned to this. Okay? So I'm going to say this. Oh my gosh.
You've lost the Spark context. No Spark context is defined. I had the same problem.
Spark.
Like the thing that gets set at the very beginning.
At the very beginning, sc.con.
Yeah, I
Yeah.
remember we tried this before, just sc.stop, and it didn't work.
Yeah. Yeah, there's a way to make it.
Stopped it.
I said no active Spark context is what I.
Okay, we could do. Okay, don't do this now. But sc dot. Can you do?
Register.
How do you? There's actually a way to do it manually, and I don't remember what it is, but yeah, mumble. Okay, so I'm gonna quit. But basically, if we had done that and it was still running, it would allow us to do that. So I think what I'll do is, for those in the room, I'm starting this again, and I'm going to get us back to that same location so we could see what would happen. Ready? Boom. Okay. So, oh no, now they're going to see my access codes. Okay, pause. There we go. Okay, baby. Okay, so we're now back in the place we were at before, but we're going to do this this pasting in of this code to write out to file, and then we will start the streaming context. Okay, there we go. Okay, so I'm once again going to do this. So we're pretending as if I didn't have to stop it. And now I'll do ssc.start. And now what's going to happen is it's going to start outputting. This time I told it to do it in outputs, so I should have said output, but this is outputs, okay? And here it's outputting these tweet words, right?
But each 5 seconds, it's a new file.
Each 5 seconds, it's a new file.
So if you wanted to batch it, you then have to. I mean, that's.
You could among other things, yeah, so this is showing it, I mean, it's cumulative though. The new ones
Oh,
include all the
previous one.
previous. Why do I say that?
Right.
It's because
'Cause you're
these
printing the whole thing.
these are the updated word counts that include the running totals.
That's right.
So, ladies and gentlemen, here are various tweet words. You could see, I mean, by the way, you notice it puts the right to left languages, I guess, over
Oh,
here.
yeah, but it's right.
That's probably
Correct.
a Kate thing.
Yeah, I don't know why it does this, but you could see there's actually just in those small number of seconds, it was what, 15 seconds on Twitter or something?
6,200 lines.
Yeah, it's quite. What's that?
Do you want to see the downward sorting of the most frequent word being used in tweets?
Yeah, how?
It's currently it's RT, but I mean it's simply just really change or updating by using the transform and then use RDB sort by its value.
Wow.
Which as Kurt mentioned before is his favorite like underbar which is 2.
Oh, I see. So you're sorting by.
The second
You do it on the RDD.
right.
I see. Okay, that's really
It's
interesting.
just a simple way for you to do the down sorting.
Okay,
To use it.
that's really impressive, Winchell.
Then-
Okay, so maybe I'll show that to the group if I could.
yeah.
But can I do it live? Probably not.
I think you can do it live because I'm doing it live.
Okay.
You probably have to cancel and set up again.
Yeah, that's the downside.
Probably have to set it up again.
Quit and set
Yeah.
up again because you.
That's what I mean by live. Yeah.
Oh yeah, that's probably.
Okay. So here we go. So, ladies and gentlemen, oh my gosh. Okay. Yeah, that's fine. I'm just replaying this so that we can now, in the final crescendo, we can put in place this mechanism created by Winchell Chin here. So this will be updated word counts, and I should have called it word count stream, as Winchell has, dot transform RDD. So for each RDD, this is something that allows you to actually map the RDDs, the resilient distributed data sets behind this, dot sort by, and we're going to sort it in descending order. So we want to make something that's bigger appear earlier. So we're going to do underbar 2. Why this 2? This is the second element of each pair
Yeah, as Kurt.
in this this value that's stored there. Okay, so really this, I'm going to write it Winchell just to be a little bit more clear. Pair dot 2, right? And you do sort by, and then you do print the top what?
10.
Top 20, let's say. What do you think? Okay, and now in the final Winchillian glory, what am I doing? SSC dot start, and we'll let the treat stream in.
I think the previous one you defined. I think the first one is always RT. I don't recognize what does RT stand for.
Retweet.
Retweet.
So that would be literally a word if that's the retweets.
Yeah.
Nice.
Okay, yeah. So A, and a lot of articles and so on early on, but yeah, that's curious. Okay, thanks to Winchell for that. That's fantastic. You notice the other things are printing out as well. These are the updated ones. unsorted, and here are the updated sorted, right? Retweets. Yeah.
It seems like wrong until a certain time go to a static of the top 10. RTA to the Quay, I, and U.
Yeah, yeah. Right, okay, yeah, so Winchell notes it reaches a fixed point in terms of its statistical distribution. But it's, in large part, that's a matter of which languages are using it and so on. Yeah. Okay, so ladies and gentlemen, that's all for today. Tomorrow we'll be meeting again. And tomorrow we're going to get into use of the Spark machine learning library. Okay? And some of the data sort of preparation components for that, and using it to perform some machine learning components. Okay? So that's for tomorrow. Thank you very much. I appreciate your flexibility. I note that this was a late announcement for this. Thank you for coming, and I'll look forward to seeing you tomorrow.